regards to my dear students. My name is Sandeep Bhatia, Assistant Professor in the Department of Electronics and Communication Engineering at Rajkumar Goyal Institute of Technology. Will deliver you a lecture on microcontroller for embedded system KEC 061. In the previous lecture, we have seen the introduction of a microcontroller, what microcontroller is, what are the various applications of microcontroller, what are the different ways to communicate with the microcontroller. We have seen the architecture of 8051, we have seen the SPI communication protocol. So, these are the advanced concept of a microcontroller. So, we will see further topics. These are the table of contents we will discuss in today's lecture. First one is the I2C communication protocol. In the previous lecture, we have seen the SPI protocol. Now, the remaining is the I2C communication protocol. We will study in today's lecture. After that, study of SPI port on 89LP51RD2. We will study in today's lecture. We have a pin diagram of, after that we will study the pin diagram of 89LP51RD2. After that we will study the pin description of 89LP51RD2, and after that we will study the MCP3304. We can also say that MCP3302. It belongs to a MCP33 family. We will discuss after few slides, and at the last we will discuss the functional block diagram of MCP3304. So, let us start with the very first topic, that is I2C communication protocol. In previous lecture, I have discussed SPI communication protocol, that is serial peripheral interface. In SPI, there was 4 communicating lines in between the master and the slave, that is a S clock, MISO, MOSI and a chip select lines, also called a slave select line. But in case of a inter-integrated circuit, I2C means basic inter-integrated circuit communication protocols, we are using two-wired interface. We are using two-wired interface. First one is the SDA and the second one is the SCL, that is system clock. So, we are going into the depth of this topic. I2C stands for inter-integrated circuit. Basically, it is a bus interface connection protocol that is incorporated into devices for serial communication. Like SPI protocol, it is also a serial communication protocol. So, it is widely used for short distance communication like SPI. SPI was also used in a short communication, short distance communication. It is a two-wire communication, as I have already discussed. As SPI was has 4 wires, but in case of I2C it has a 2 wires. It has 2 wires. I2C has a single or in some cases multiple masters or single slave or in some cases multiple slaves as well. Serial communication protocols, it means that we have the freedom to attach multiple IC at the same time with the bus. This is the architecture of I2C communication. In this architecture, you can see that we have a single master and we have a multiple slaves. Master is communicating to the slaves through a 2 signal SDA and a SCL. SCL. This is a serial clock and this is a system bus. So, master may be a microcontroller and slaves are the devices like ADC, DAC, microcontrollers as well. So, all are communicating through a system bus. There is another bus, that is a VDD. This is a open drain terminal. It has internal pull up registers. So, basically it is used to trigger the IC pin. Now, coming to the next slide. So, in the I2C protocol, communication is always started by the master. Communication is always started by the master, and in the case of multi-master, only one master has ownership of the I2C bus. So, basically in I2C protocol, if there is a single master, that single master has all the control, they are controlling the slaves. But in case of a multi-master, if we are using multi-master, then one master has the ownership of the controlling the slaves. So, I2C only uses 2 wires, as we have seen in the previous lecture that SPI has 4 wires and I2C shares 2 wires in between the devices. So, first one is the SDA, serial data, and the second one is the serial clock. So, what serial data is do? The line for the master and slave to send and receive data, and the serial clock is the line that carries the clock signal. We have seen that ki I2C need IC need clock pulses to execute its operation. So, these clock pulses are sending through a SCL line. It carries the clock signal from the master to the slave, and all the data which is after the clock signal is provided from the master to the slave, the communication takes place through the SDA bus, serial data bus. So, we can say that in I2C communication, data is transferred bit by bit along a single wire. This is basically a serial communication in which data is transmitted bit by bit. Now, coming to the next slide. With I2C, data is transferred in the form of messages. Messages are broken into frames. Here you can see in this diagram, we are transmitting the messages from the master to the slave when the clock signal is provided from the master to the slave. So, messages are break into a further parts. We have a start condition, we have a address frame, we have a read write bit, we have a acknowledgement, no acknowledgement, ACK means acknowledgement, and NACK means no acknowledgement. After that, there is a data frames which is followed by a ACK and NACK. We have a stop condition as well. So, message is broken into a parts, and each message has an address frame. I have already discussed that, which contains the binary address of the slave. To which slave it is communicating, it provides the address bus to the address frame. So, message also includes start and stop condition. Start means represents the start of the pulses, and the stop represents the end of the pulses. So, we have other signals read write bit, ACK, NACK in our message frame. Let us discuss these broken parts one by one. So, first one is the start condition. Start condition basically represents the start of the pulses, and stop condition represents the stop of the pulses. So, start condition basically it works on the rising edge, that is when the pulse is takes a rising edge, that is flow from the low to the high, and the stop condition works on the falling edge when the signal takes place from the high to the low. So, after the start condition there will be a address frame. Address frame basically carries the address, it may be a 7 bit or 10 bit, and it goes to the particular slave. After that, we have a read write bit. Microcontroller works on the whether read or write operations, whether it is reading the data from the particular microcontroller or whether it is writing the data into the microcontroller device. So, there are read and write operations possible in our I2C communication. We have a ACK, NACK bit. ACK means acknowledgement and NACK means no acknowledgement. So, basically our data frame is followed by ACK and NACK. ACK means acknowledgement from the slave to the particular to the master that they are getting the data from that master device, and no acknowledgement bits means that there is no address frame received by the slave from the master. So, it is followed by a ACK and NACK. This is advantage for I2C communication as well. So, coming to the next slide. Now, we will discuss in this slide, we will discuss the advantages and disadvantages of our I2C communication protocol. Advantages of I2C communication is that it uses only 2 wires. It has only 2 wires. We have already discussed in our previous slide that it has only uses 2 wires. First one is the SDA and S clock, as compared to SPI which uses 4 wires. It supports multiple masters and multiple slaves. It has 2 wires, so hardware requirement is somehow less. It has a ACK and NACK bit which gives confirmation that each frame is transferred successfully. With this feature is not available in SPI communication protocol. It is a well known and widely used protocol. among all the available serial communication protocol devices in the market. Disadvantage of using I2C communication protocol is that it has slower data transfer rate than SPI, because here we are using 2 wire only, so it has a slower data transfer rate than SPI protocol. The size of the data frame is limited to only 8 bits. This is a disadvantage. We can at a time we can we can transmit data only 8 bits. More complicated hardware needed to implement than SPI. Basically it has 2 wire, but we can say that in a multi-slave or multi-master architecture, we need more hardware requirement for its operation. So, till now we have discussed the SPI communication and I2C communication in today's session. Now, let us start with the SPI port study on 89LP51RD2. Now, we should know what is 89LP51RD2. 8951 means the series of 8051 microcontroller, LP means the low power modes, low power operation, it has a low power operation, RD2 is the family it is represented. So, first of all we will start with the features of 89LP51RD2. First feature is it is a 8-bit microcontroller, like 8051 it was 8-bit device, it is also a 8-bit microcontroller with 8051. It has compatibility with the 8051 products. Basically, it is a enhanced 8051 architecture. In lecture 1, we have seen that the review of basic architecture of 8051. This is the enhanced version of the 8051 microcontroller. It has a single clock per byte fetch. In 1 byte, it can send a single clock execution. It can do single clock execution. It has a 12 clock per machine cycle. What is machine cycle? Machine cycle is basically a step of execution followed by a processor upon receiving the machine language instructions. So, it is there is up to 20 millions of instruction per second. MIPS means millions of instruction per second throughput, that is at a given input how much output they are providing, it is called a throughput. So, at 20 megahertz clock frequency it is providing 20 MIPS signal. So, it has fully static operation from 0 hertz to 20 megahertz. Static operation means it works on the static RAM rather than the dynamic RAM. It has a static operation. So, if we see in a dynamic RAM, there is a capacitor which when it is charged, there is a addition of data, that is a storage of data. When it is discharged, there is a deleting of the data. So, it works on a it has a static operation rather than the dynamic operation. It has a on chip 2 cycle hardware multiplier. Multiplier means which is multiply the input, which is amplify the signal. It has a 16 into 16 multiply accumulator unit, and it has 256 into 8 internal RAM. Basically, you can see here 16 into 16, 256 into 8. Basically, it represents the size of the microcontroller, size of the chip available to the users. So, this represents the size of the chip. Now, we are going some more features. We will discuss some more features. Next feature is it has a on chip 2 kilobyte expandable RAM. On chip means all the components are integrated on the same chip. It has a on chip memory available, that is. So, it has one important features among other microcontroller. 89LP51RD2 have main feature is that it has expandable RAM, that is RAM is extendable up to 2 kilobyte. It is available on chip, not we need do not need to connect externally to the microcontroller. So, next feature is that it is software selectable size. Among the 7 sizes available 0, 256, 512, 768, 1024, 1792, 2048 bytes. We can select these microcontroller have features to select particular sizes upon which it has to work. After that, we have a dual data pointers. We have a 4-level interrupt priority. It interrupts priority means basically to which interrupt it has to deal microcontroller. Basically, if we are taking a real type example, if we are going to the market to purchase medicines or some daily needs accessories, and if we have a patient at our home, what we will do? We will purchase medicines first. On the same concept, microcontroller upon receiving the interrupt signals, they based upon its priority, they will handle the interrupt. So we have a non-volatile program and data memory. Non-volatile memory means the which is that is a ROM. So it has 64 kilobyte of in-system programmable flash program memory and 4 kilobytes of EEPROM memory. ROM basically represents the real only memory, but we are seeing today that we have a USB card readers as well. They can be a ROM, but they in these devices there are both the operation, that is read as well as the write operations. So it has a 4 kilobytes of EEPROM, that is the electrically erasable programmable read only memory. It has a operating conditions, that is from 2.4 volt to 5.5 volt VCC voltage range. In this is the range of the 89 LP51 RD2. In this range it will work fine, that is from 2.4 to 5.5. Beyond 5.5 and before 2.4 volt it will not work. After that we have a 40 degree Celsius to 85 degree Celsius temperature range. Within this range it will work fine, and we have a 0 to 20 megahertz. Basically this is a minus 40 degree to 85 degree Celsius, and after that it has a 0 to 20 megahertz in a single cycle. It has a clock pulses. So these are the features of 89 LP51 RD2. Now let us see the go through the pin diagram of 89 LP51 RD2. In this pin diagram you can see there are 40 total, there are 40 pins. This is dual inline package. This pin diagram is similar to what we have studied in 8051 pin diagram. There are 40 pins and there are 4 ports here: port 1, port 2, port 3 and port 4. You can see that each port has some specific function, except port 4 which has only a general function. So we will not discuss each port and each pin in much detail. We will deal only with the port 1. Port 1 we will discuss port 1 only. Why port 1? Because in port 1, because our topic is the SPI port interfacing with the 89 LP51 RD2. So SPI, in SPI serial communication protocol, there are 4 signals available. So these 4 signals are available in P1.0, P1.1 and P1.5, P1.6, P1.7. In these 4 pins, their SPI signals are available. In port P1.1 there is slave select lines. In P1.6 there is MISO line. In port 1.6 there is MISO line. MOSI line is available in P1.5, and in P1.7 the line available is MOSI, that is system clock. Basically system clock cycles are providing through P1.7. So in next slide we will discuss one by one all these lines, that is P1.0 and P1.5 to P1.7. Let us discuss one by one. So P1.1, it is basically a slave select line. Pin number 2, it is available in pin number 2. So this is a user configurable input output port 1 bit 1. User configurable means that user can be configured either in the ADC or DAC modes. ADC means analog to digital conversion and DAC means the digital to analog conversion. So it P1.1 means port 1 bit 1. Similarly, if we can say port P3.2, port 3 bit 2. So it has a T2EX line, that is a timer 2 external capture or reload input mode. External capture or reload input means that if timer are capturing the data, they are getting the data and reload into the input device. It has a slave select line, that is SPI slave select line. After that there is another line available, that is P1.5. It has a MISO operation, master in slave out. It is available in pin number 6. It has user configurable input output port 1 bit 5. So 1.5 represent port 1 bit 5. So it has a MISO operation. MISO means that SPI master in slave out. So master MI means, what is MI means? Master in slave out. When it is when configured as master, this pin works as an input, and slave output means that when slave is configured, it works an output. So MISO means master works as the input and slave act as a output. So when configured as slave, this pin is an output. MOSI means that SPI master out slave in. That is MOSI. Let us discuss here. MOSI, that is master out slave in. When it configured as a master, it works as an output device. When it configured as a slave, it works as an input device. So MOSI means master works as an output device and SI means slave works as an input device. So when configured as a slave, this pin is act as a input. So during in system programming, this pin is an input port. Basically in a default mode, it works as an input mode. If we do not have any particular configuration for the input and the output, this works as an which mode? Input mode. Now we have left with the two pins. Next one is the P1.6, that is user configurable input output port 1 bit 6. So port 1 bit 6, this is a system clock. We need clock for the execution of the IC. So SPI clock. So SPI clock, what should be the direction of the SPI clock? From the master to the slave. Why? Because master is controlling the things, they are providing the clock's pulses to the particular slaves. So in this mode, as system clock, when configured as master, this pin is an output, and when configured as slave, this pin is an input port. MISO, SPI master in slave out, this is a works on the remap board. When configured as master, this pin is an input. When configured as slave, this pin is an output. So during in system programming, in the default mode, it works as an output mode when there is not any specific configuration for the input and the output. After that, we have a P1.7, that is MOSI pin number 8. So this is basically user configurable. It can be configured by the user in ADC or DAC mode. That is a pin port 1 bit 7. MOSI, basically SPI master out slave in, as we have discussed that in MOSI, when it is configured, this when slave is configured, this pin is an input. And system clock, when configured as master, this pin is an input, and when configured as slave, this pin is an output. And during in system programming, this pin works as an input mode. By default, it works as an input mode. So basically we should know what is MOSI and what is MISO. So MOSI basically master out slave in. When it works on when it configured as master, it works an output device. And what should be the mean of MI? When master is configured, it works an input device. So these are the explanation of the pins. Now we will study the MCP 3304. So basically why it is you have seen 33 here, because it belongs to the MCP 33 family. In this family, there are other members available like 3304, already we have seen here, 3302, and it works on the two mode B or C. So MCP 3304 is basically a 13-bit analog to digital converter. Which has features like full differential input. It has a full differential. What is the meaning of differential? The voltage is applied. There is a difference between the input voltage to be applied to the particular chip, and it has a low power consumption. Among all microcontrollers level, it has a very low power consumption, and it works in a small package. So that is ideal for battery powered system, and it used in remote data acquisition applications. This can be used in our transducer interfaces as well. So the industry standard SPI serial interface enables 13-bit ADC capability to be added to any PIC microcontroller. So let us discuss the important features of MCP 3304. First feature is the 100 kilobyte samples per second. At 1 second, it can sample up to 100 kilobytes of samples. It has a one input channel. It has a low power consumption. Main feature is that it has a low power consumption. 300 nanoampere has in a standby mode, and 400 microampere in a maximum active mode. So this is one of the important features of a MCP 3304. After that, it is available in a 16-pin PDIP package and SOIC. What is the meaning of PDIC? Plastic dual inline package, and SOIC means small outline integrated circuit. SOIC has an advantage over PDIP is that in SOIC there more miniaturization is possible. Why? Because because the consumable area can be reduced by 40% to 50% in case of SOIC. It has more efficiency than the PDIP packages. Now, let us discuss some more important features of MCP 3304. The full differential inputs of the MCP 3304 enables a wide variety of signals. To be used in applications such as remote sensors, portable instrumentation, and battery operated applications. We can use MCP 3304. So, MCP 3304 is basically a user programmable. User can be configured in either in the ADC mode or DAC mode into 4 differential input pair and 8 single ended inputs. So, MCP 3304 is basically available in 16 PDIP package. Here you can see 16 pins, 1 to 8 is the analog inputs, and this is the VDD with reference voltage, 2 grounds, analog or digital ground. They share common ground. D out, serial out, serial in, chip select. SHDN means shutdown input, and it needs clock pulses to execute. This is the functional block diagram of MCP 3304. In this functional block diagram, input is provided by the CH0 to CH7. That is, analog inputs are providing through this, analog inputs, not digital inputs. So, in 3304 there are 8 analog inputs, and in 3302 there are 5 analog inputs, that is CH0 to CH4. These inputs are provided to the input clock, input channel multiplex. Further, they store the data into a sample and hold circuit. V reference is applied to the CDEC, and the comparator compares the V reference voltage, this is also analog voltage, with the sample and hold circuit, and the result is further provided to the 13-bit successive approximation registers. What is CDEX? Capacitive digital to analog converter. It is compatible with the comparator, that is we are using with. After that, the output from the 13 bits SAR is available to the control logic. Control logic will control or decide or generate the output for the shift register, and finally from the shift register we can get output, the output, and this is available. Other pins are also available. In our next lecture we will discuss more about the MCP 3304 and the SPI port interfacing with it. So, we are ending our session here. I hope you have enjoyed the lecture, and I hope you are safe and healthy at your place. Thank you everyone for your patience. Thanks.